Oh, well, hello there. I didn't see you. Oh, what's that? Oh, you want to learn how to calculate an efficiency score? Oh, that's terrific! Because today we're going to be covering just that thing in lesson number 13, how to calculate an efficiency score. Now, you can calculate your efficiency score directly from the data that you've obtained from your SAP analysis. You cannot do so with your economy score, and we'll cover how to calculate an economy score, or approximately calculate it, in a future lesson. But for now, focusing on efficiency, I'll be referring to the rules in 2014 just for an example, and pretty much hopefully you remember from the previous lessons that there were a couple of deflection points that we were interested in particular vertical deflection points, as well as lateral deflection points. So I've labeled those appropriately in my SAP model, as you probably remember previously, and you can use the same kind of naming convention, and probably the best way to go about setting up something to calculate your efficiency score would be to just go ahead and do something like an Excel spreadsheet, like I've got here. So pretty much I've highlighted in blue all of the deflections that I need to pretty much pull out of my SAP model in order to be able to calculate all the efficiency scores for all the load cases in my particular model. I also need to have the total weight of the bridge in order to be able to calculate the weight cost. Now, how do you do all this? Well, it's pretty simple. All you have to do is know which particular load case you're going to be looking at. You need to know which step, either the preload or the fully loaded step, you're looking at, and you need to know which particular deflection target you're getting the deflection value from. After that, all it boils down to is just filling in the table. So let's give an example. Let's go to our SAP model, run your analysis, and I'm just using the same model as from our previous lesson, and let's go to our deflections and go to our first load case and step. So load case 1, step 0. Case 1, step 0, bam. Now let's go and get that first deflection target, the D1A. And if you remember, my D1A target is right here, the S1D1. I'm going to just pull that off as the U3 value, minus 0.0225. So, minus 0.0225. Now, D2A, what's this? Negative 0.0145. Negative 0.0145. Alright, we're on a roll. Now let's go and get those case 1, step 2 values to fill in these two. Why am I skipping D1B? Well, I'm saying my bridge is symmetric, so I'm skipping over that. Now let's get D1A. It should be right here, and it's negative 0.229. Alright. And if I'm going too fast, feel free to rewind. And negative 0.1834. Alright. Now I've got all my deflections I need for my case 1. All I need is the weight, and you can get your weight pretty simply by just going up to Display, Show Tables, Structure Output. Mind you, you have to run your analysis first to get these. The Structure Output and select Base Reactions. You'll want to have at least your dead load selected for the cases selected for output. You can select all just to make it easy though. So under dead load case, you'll see a global FZ, and this is basically the summation of all of the vertical reactions at your basically restraints in the model, which for the dead load case ends up just being the summation of the total weight of the structure. Pretty easy. Here it's measured in kips though, which gives pretty poor accuracy. So instead what I'll do is change the units of my model to pounds, inches, and Fahrenheit. Do the same thing, show tables, make sure I get structure output, and then I can pull off what it is in pounds. So 89.66 pounds. And I can directly plug that into my spreadsheet. Now I have my efficiency score calculated for load case 1. And you can do the same thing for your other load cases as well. You can also do the same thing for your lateral load case, but remember how I had said previously that you might, in this case, want to actually go back into your model, change your base, oh dear, where'd my bridge go? You can change your bridge such that these two base points, say, might have different restraint configurations, such as rollers, which might actually prove to be significant. Now, I would recommend maybe doing it both with pins and maybe with a combination of pins and rollers, seeing if that makes a large difference. And if it doesn't, or if your deflection, your lateral deflection, isn't a controlling limitation of your design, then you can just do the whole thing simply with pins. Now, how do you do this efficiently? Because you're probably saying, oh geez, this is going to take forever to do this. And if this is just one iteration, then indeed it's going to take you a while just to fill in all these values by hand. So let's take a look back historically. So Danny Savannah actually had a very nice kind of scoring spreadsheet that he had constructed, and I borrow some of the ideas that he had presented just kind of as a matter of concept. Now, he had basically hard-coded references to one of his external tables from SAP, pretty much. So what are these values that he's calculating as the deflection points? Well, basically, this table is directly output from SAP. You can actually have SAP directly output this table. And that was a bit redundant, but I'll show you what I mean. Let's go to, and I've already run my model, not that, but display, show tables, and instead of doing structure output, I can go to joint output and select displacements. Select all your load patterns. And here I have a similar table, pretty much. Now I can get this table in an Excel sheet by going to File, Export the current table to Excel. And here it pops up with the nice little Excel table. It'll read out which particular joint we're looking at, what type of load case that we're particularly looking at that's been run in the analysis, and what the joint displacements are, so the U1, U2, and U3 values. That's great. We can use this data pretty much directly in order to calculate what our deflection scores should be. Now, there's a problem here because I've only selected a couple of the points, as you can see. And that can be nice if you only want to output joint data for maybe these 2 points, which I've selected. But I want to select everything, so I'll deselect everything, go to Display, Show Tables, do the same thing, and it should output now all of the joint displacement data for all of the joints. So yummy, yummy, yummy. I'm going to just go ahead and Control A to select them all and copy it. Now I'm going to go into my own spreadsheet and go to my SAP Deflections tab. And here I have a default tab just to allow for the input of these sort of tables of deflections. And there I just do Control V to paste it all into my Excel spreadsheet, and oof, I have all this data. But how am I going to sort through it? Well, you can actually construct some very clever Excel functions to sort through this data for you, which I've already done in this auto efficiency scoring spreadsheet. So there's some pretty complex, much more complicated, I would say, than some of the things that Danny had attempted. And I would not advise necessarily poking too much into this yet, unless you're very curious and you want to use this kind of stuff. Basically, I'm using array functions and a whole bunch of fancy stuff, but you don't need to know that. Basically, I'm just kind of pulling out those values from this spreadsheet in a very fancy manner and then organizing them here. Now, the only thing I need is the weight, but I can do a similar thing when I go into my display output, show tables, and when I do structure output, remember I have it in pounds specifically, I can do the same thing. File, export the table to Excel. I can copy this whole table pretty much into my SAP Base Reactions tab now, different tab, and it automatically populates what my weight should be. Now this also does it for the case where all my supports are pins. If you wanted to do it for these two supports as rollers, then you'd have to basically hard code those values in and read them off by hand. But otherwise, I did in pretty much seconds what it would have otherwise taken in maybe minutes. So if you're doing several iterations over and over and over again, this can save you quite a lot of time. So I would encourage you to explore some of the options of Excel, get familiar with maybe certain things like Excel logic functions, array functions, and the index match tool or VLOOKUP functions, which are very, very powerful tools in Excel. If you can master those, you will be ahead of the game. Because I will say, as a heads up, word of the wise, if you take ECI 173 Foundation Design you're going to want to know how to use Excel efficiently, and this is a very good way to practice that. So you can go ahead and take a look at these files just to see how I've formatted it, and hopefully it'll be informative. I've done a little bit of extra fancy stuff here, so you can maybe get some inspiration from that. I'll also upload Danny's spreadsheet just for posterity. Alright, well, hopefully that was good. I will see you guys next time.